At GreenLab, we engage with many different research projects focused on green energy, flexibility to green energy, and cultivating green energy clusters and bringing industries together. The work that I do mostly involves me interacting with university partners and industry partners and bringing them together to work on projects with GreenLab. One of the big challenges we face at the moment is how do we provide energy to our growing energy demands without producing carbon dioxide into the atmosphere. Now, one of the ways that we can do this is through creating what's known as green hydrogen. That is hydrogen that's generated through electrolysis, where the electricity that's provided to separate the water into hydrogen and oxygen is provided solely from green energy. If we do this, then all of the value chain from the water to the hydrogen can be considered green. Then we start to look into projects where we can start to use this hydrogen to replace things that are traditionally using fossil fuels, like steel industry, for example, or using it to balance the electricity grid instead of natural gas. This is becoming very relevant for us now at GreenLab, as we have laid down the first electrolyzer in the park, which is part of a 100 megawatt electrolyzer project called Green High Scale. So we will start to need a lot of water to be used in our park. As we start looking towards these projects, we run into issues when it comes to how do we source this water? Is it okay for us to use drinking water? Is it okay for us to use wastewater? Who should treat this? How pure does the water need to be? Does that affect the lifetime of the electrolyzers? What is the trade-off economically? Lifetime assessment of the equipment? What has the most environmental impact? Because of these challenges that we're facing, we've partnered with researchers from D2 Sustain.
Water for Power-to-X has two implementations. One is for the quantity. So we need roughly 1 million cubic meters per year for 1 gigawatts of Power-to-X. How do we get it? So one part of our task is to map the water source, especially in industrial park like GreenLab. And the second implementation is about the water quality. We need ultra-pure water. How do we transform the wastewater or surface water into ultra-pure water that can be fed to the electrolyzers? So we are going to investigate the technology pathway. Which technology is the best, cheapest, and most sustainable to produce ultra-pure water for electrolyzer?
Because of this project that we started, we had CERN from NERUS reach out to us. NERUS are providing the water on site for our electrolyzer projects, and they were really interested in this project that we had started with Angela and wanted to help and contribute to this project.
In this case, what we are helping companies on in GreenLab is try to see how can we make renewable electricity into renewable fuels. And for doing that, you really need a lot of water. And you need water of an ultra-pure quality, otherwise you cannot make these really advanced industrial processes work.
As you can see from this, there are many different ways that we can look at this problem of providing water to electrolysis. It can be from a regulatory issue of what water can we use? It can be an economic issue of who should pay for the wastewater treatment or the purification of the water that goes into the electrolyzers. It can be the technological challenge of how much energy is it okay to use in the purification, and what percentage of that needs to be balanced with how much energy is produced. We see these ideas as wicked problems where there are big issues to solve with many different ways that they can be solved. We would like students to come in with their various different competencies, with their ideas and a passion to tackle this challenge, to work with us and to add their little bit towards the solution so that we can all work together to solve this problem.